All efforts have been made to ensure the information presented is accurate at the time of recording. Any references made to implied functions remains at the discretion of Broadcom and can change at any time. Welcome, my name is Andrew Firth from the VCF Technical Marketing team. Here, I'm going to show you through the new features and functionality that's been added into VMware Cloud Foundation 9. What we're going to cover here are our second set of use cases for VCF 9, which is focused around delivering a unified cloud experience for developers. We're going to start with infrastructure for Kubernetes. The vSphere Supervisor is an integral part of the cloud experience story. The supervisor is an embedded declarative API, allowing customers to deploy and manage virtual machines, Kubernetes clusters, and other resources, all on the same platform and using a unified set of tools. On enablement, it provides a set of core supervisor services, which include the VMware Kubernetes Service, VKS, which allows customers to deploy and manage fully conformant Kubernetes clusters, the VM Service, which allows customers to deploy virtual machines using desired state, the Networking Service, which allows customers to deploy load balancers on demand, and Storage and Data Services, allowing customers to deploy persistent volumes on demand. Customers can deploy additional supervisor services, providing additional functionality for their workloads, like an image registry, such as Harbor, or a secret store. The vSphere Supervisor is a Kubernetes-based ecosystem that's highly extensible, allowing us to introduce new services while maintaining the same consumption experience. From VCF 9, cloud admins can quickly and easily enable vSphere Supervisor as part of workload domain creation. VCF Operations contains inbuilt workflows to create new workload domains, pre-configured with the vSphere Supervisor. This option provides an opinionated way of deploying Supervisor and relies on minimal input from customers. This deployment model utilizes NSX projects and VPCs, which can be configured as part of this workflow using options selected from the drop-down menu. It's important to note that customers do need to complete a NSX Edge deployment after workload domain creation when the supervisor is enabled. Now, vSphere namespaces form a resource envelope for workloads. They're similar to resource pools, but with extended capabilities. They allow customers to set resource allocations, quotas, and limits, but also define storage policies and zones. They also provide basic configuration options for VKS and the VM service, such as configuring content libraries and associated VM classes. vSphere namespaces also provide workload isolation for organizations, whether they want to provide isolation for applications or perhaps group them by teams. They may also want to split namespaces according to various states of development, such as tests, staging, and production. Now, to provide greater network isolation, vSphere namespaces with VCF 9 now integrate with VPCs. DevOps teams can configure network isolation via VPCs without needing to understand the details of the underlying network. They can create these using existing VPCs, or they can create their own based on VPC connectivity profiles configured by administrators. DevOps teams can also assign their own private IP ranges as part of VPC creation, as they don't impact their networks. From VCF 9, customers can now easily scale the supervisor. So additional vSphere zones can be easily added to supervisor capacity. You don't need to deploy supervisor control plane VMs on each cluster, although the option is still available to you. Additional vSphere clusters are added as a vSphere zone to the supervisor. This also allows the supervisor control plane VMs to be segregated from workload VMs and vSphere Kubernetes clusters on separate vSphere clusters or vSphere zones. Once again, of note, vSphere namespaces can be created to span one or more vSphere clusters or vSphere zones. Administration of a supervisor and its services involves a combination of vCenter and supervisor cluster privileges. Because of this, it's been challenging to delegate supervisor-specific responsibilities to VI admin users. Now, with VCF 9, the supervisor honors permissions from vCenter, allowing the VI admin to assign the new supervisor admin role to their users. This means that corresponding Kubernetes roles are created to map to the vCenter permissions. Users with this new supervisor admin role can do things like configuring namespaces, set limits, add reservations, handle access control, and manage storage policies without full administrative access. The administrator role extends beyond an individual supervisor and allows configuration of the supervisor and its supporting services. With vSphere 8, supervisor releases are delivered via vCenter patches and updates. In vSphere 9, supervisor releases are decoupled from vCenter. This capability now allows supervisor clusters to be patched and updated independently of vCenter, which allows more rapid delivery of new supervisor releases and functionality to developer teams. Let's next talk about private AI with VCF 9. VMware Cloud Foundation 5.x introduced a number of new orchestrated workflows to simplify the configuration of a private AI platform, inclusive of the infrastructure stack, Kubernetes runtime, and AI ML cloud templates. This joint solution with NVIDIA is known as VMware Private AI Foundation with NVIDIA, and it's available as an advanced add-on service to run together with NVIDIA GPU devices and the NVIDIA Private AI Enterprise Suite. VCF 9 takes this further, allowing admins to configure private AI from within the vSphere client, which can be configured using a new set of powerful private AI services. The process to deploy VMware Private AI in vSphere is initiated from within the vSphere client. Let me play this demo again. A VMware Private AI Foundation add-on license is required. Private AI infrastructure can be deployed in cloud-connected or cloud-disconnected mode. Orchestrated workflows guide the VCF admin through the deployment steps to configure private AI infrastructure. Once infrastructure is deployed, consumers, such as data scientists and AI developers, can utilize this platform to support different AI application types, such as deep learning virtual machines and Kubernetes clusters, applications based on NVIDIA NGC container images, and vector databases for retrieval augmented generation. Private AI workloads can then be deployed by consumers using the self-service catalog from VCF Automation. Another key benefit of this on-prem private AI solution is that the underlying hardware and SDDC-based infrastructure is all deployed, scaled, and lifecycle managed by the VCF administrator. Private AI services are new to VCF 9 and streamline the deployment and management of Gen AI workloads for enterprise customers. Private AI services appear as the supervisor service that is added to the supervisor. VI admins can view and manage private AI services in supervisor services in vSphere. For the purpose of today, let's go through this a little bit deeper with some extended talk points. On the diagram is an example of how a model is consumed during its lifetime. Models are pulled from online sources such as Hugging Face, NVIDIA NGC, and others. Data scientists validate these models for use with private AI in a DMZ environment. The Harbor registry can then be used as a model store for storing internally validated and secure models, which can be used by MLOps teams. Next, model runtime is used for inferencing and embedding models. Model runtime can then be shared and accessed with the appropriate teams and then published to a service catalog, which can be multi-tenanted using VCF automation. MLOps teams can then consume available models running in a namespace and connect with model endpoints, which include the data indexing and retrieval service and the agent builder service. An API gateway can also be configured, which provides a stable and secure interface for accessing model endpoints. The data indexing and retrieval service is used to connect different knowledge bases, which are used to load relevant data embeddings into vector databases. The agent builder service is then used by developers to build, test, iterate, and serve AI agents, which is used with an API endpoint to a front-end customer application. Data indexing and retrieval services and tools and the agent builder services and tools have separate UIs of their own.